Hey guys, we're going to be working with the radicals again, but we're going to do some operations with them. We're going to add, subtract, multiply, all that kind of stuff. But I want you to remember first off how we reduced them. We've done this before, it's been a while, but we used the perfect squares: 1, 4, 9, 16, 25, 36, 49, etc., right? And so if we had the radical 32, we'd say, all right, well, 32 would be about here in the list. And then we start going through, does 25 go into it? Does 16 go into it? Aha, twice. So 16 and 2. And then we could break that down. The square root of 16 is 4, so it's 4 radical 2. We've done that. It's been a while, but we've done that before. I'll do a couple more here. If I had one, I'm going to start with my perfect squares on the top. And let's say I got radical 18. So 18 would be about here. And we start working back. 16 doesn't go in, but 9 does. And so we've got 3 radical 2, because the square root of 9 is 3. We're looking for that perfect square. All right. So that's an important skill that we're gonna need, but it's not the only thing we're gonna do today. But we still need to remember how to reduce these radicals. Okay. So let's try one more. Let's go to the square root of 27. So we got 1, 4, 9, 16, 25. 27 would be here. 25 doesn't go in, 16 doesn't go in, but 9 does. And so we got 3 radical 3. The 9 becomes that 3, right? Because it's a perfect square. All right. So now the idea behind this is sometimes we can add radicals together or subtract them, but only if they're the same. So if I had 2 radical 7 plus 3 radical 7, what would that be? Well, that'd be 5 radical 7. Just like if we had 2x plus 3x, we'd call that 5x, right? It's the same idea. We can treat this the same way. Or on the other hand, if I had 2x plus 3y, can I add those two together? No, because these two are not like terms. So by the same token, if I had 2 radical 7 plus 3 radical 5, I have to leave these separate, okay? Unless these guys could be reduced. And in this case, they can't. But if we could do what we did just a minute ago, we could reduce those, and maybe we would be able to add them up. Okay, but at this point, right here, this particular one, we can't do anything with. So let's say we've got 4 radical 5 minus radical 5. Well, if I had 4x minus x, isn't there a 1 there? So that would be 3x, wouldn't it? So there's still a 1 there. So it's going to be 3 radical 5. So anytime I have the same radical, I can add and subtract. Okay? What if we had like radical 3 plus 2 radical 2 plus 4 radical 3? It's the same idea. I got x plus 2y plus 4x. I can put some of them together. I could call that 5x plus 2y because these two would go together, right? So the same thing here. These two go together. So I got 2 radical 2 plus 5 radical 3. Okay, because remember, there's a 1 here. There's a 1 here. All right. So we can add and subtract radicals as long as they're the same. But when they're not the same, what do? Well, let's say we got radical 18 plus radical 2. Those obviously aren't the same. But can this guy reduce? Well, 1, 4, 9, 16 would be there. 16 doesn't go in, but 9 does. How many times? 2 times, right? And then this is going to become a 3. So now, again, there's a 1 there, so it's going to be 4 radical 2. So I can add those together. That will work, okay? Let's try another one here. Let's go 5 radical 3 minus radical 12. Again, looking at it, they're not the same. I can't do anything with it unless this guy can reduce. Well, let's see. 1, 4, 9. So 12 doesn't go in, but 4 does. So I got 5 radical 3 minus radical 4. Oh, radical 3. Now, what's radical 4? It's 2, isn't it? So now I got 5 minus 3. That's going to be or 5 minus 2, I'm sorry. That's going to be 3 radical 3. All right? So those are my basic operations that I can do when I add and subtract, okay? I can do any of that stuff. As long as they're the same radical, I can add and subtract them. Can I multiply radicals? You betcha. If I had radical 3 times radical 2, well, that's just going to be radical 6. The thing I want to look for is, does this reduce? No, it doesn't in this case. But what if I had radical 4 times radical 7? Do I want to go radical 28? Or can I reduce this guy first and just call it this? Because wouldn't I have to reduce him? I'd have to go, oh, that's 4 times 7, which is, you know. So if one of these can reduce, you do it first, if you can. And it might turn into something that can reduce. Okay? Let's try another one of those. Let's go radical 5 times radical 2. That would be radical 10. What about a radical times itself? That's radical 25, but what's the square root of 25? So, wait a minute. Any radical times itself gives me the number that's underneath the radical. So if I had radical 6 times radical 6, that's going to be 6. If I had radical 3 times radical 3, that's going to be 3. Because really, 6 times 6 is 36, right? Isn't the square root of 36 6? 3 times 3 is 9. Isn't the square root of 9 3? So any radical times itself is the number underneath the radical. All right, let's try another one here. Let's go radical 2 times radical 8. Can this guy reduce? I mean, I could. I guess I don't have to. I could just call that radical 16. And how much is radical 16? 4. Okay. But if I reduce it first, what goes into 8? 4 does, right? How many times? 2 times. So now, check this out. What's this? 2. And what's this times this? And now what's this? Look at that. It's the same thing. That's kind of a weird version of it. But it was easier to do it this way. But sometimes when you get larger numbers, it might be easier to break it down first. My wife is looking at me in amazement. We'll do another one of these later. But so there's more than one way you can do this each time. Sometimes the easier way is just to go straight through it and you might get this large perfect square. Okay. Let's try another one of those. Let's go radical 3 times radical 6. Okay, so neither one of these breaks down. So I just leave it radical 18. But now this is reducible. I got 1, 4, 9, 16. So 18 would be here. 16 doesn't go in, but 9 does. So it's radical 9 and radical 2, which is 3 radical 2. Okay. Let's leave it at that for today. Let's do one more. We'll do some division tomorrow, maybe. What if I had radical 5 times radical 6? That's going to be radical 30. Is this reducible? I don't think there's a perfect square that goes into 30. Okay, what about radical 8 times radical 6? That'd be radical 48. Now, I'm guessing that that's reducible because this is reducible. But let's see here. 1, 4, 9, 16, 25, 36. 36 doesn't go in. 25, 16. I think it goes in 3 times. So it'd be 4 radical 3. Okay. All right. I'm going to give you a couple problems to work on a worksheet, and then I'll get back to you with some more of this tomorrow. Good luck.